Here in instrumentation, so much of the day-to-day controlled, repeatable, standardized testing that IBHS does happens. And to talk through the testing that occurs here at the cone calorimeter, I'm joined by our cone calorimeter lab technician, Dory Sonolis. Dory, tell us about this machine.
Yeah, so we are standing in front of the cone calorimeter, and I'm going to walk you through the calibration sequence that's done every single day because it does require an hour and a half setup before any testing can be done.
Wow, that's part of the controlled, repeatable part of standardized testing.
Absolutely. So we follow ASTM E1354.
Okay.
And some of the things that are dictated by that standard is part of the calibration sequence.
Okay.
So first and foremost, we're required to have 24 liters per second of airflow moving through the cone at all times.
Okay.
That's the first calibration of the day. The second thing is the laser that runs directly through the stack here. The laser is used in the smoke production rate calculation. The third and the most important, in my opinion, is this gas analyzer.
Okay.
The gas analyzer is really important because we use oxygen consumption calorimetry. So if our oxygen value is not correct at the start of the test, the entire results throughout the test will be skewed. The next thing that is calibrated is the heat flux.
Okay.
So this gold piece is our cone. And we are required to make sure that our cone is reading a specific heat flux in kilowatts per meter squared. So,
and that heat flux is what you can vary as you're testing, right?
So it will stay constant throughout the entirety of the test, but we can test at several different heat fluxes. Just requires an additional calibration to get there.
Awesome. Okay, so once you've done all of this calibration that you said takes about an hour and a half, what is the next piece of your setup?
Yeah, so the next piece of the setup is going to be prepping the sample, which I have already done.
What are we going to be testing today?
So we are going to be burning a piece of wood siding.
Okay.
It is the same wood siding that is on our ADU behind the chamber.
Okay.
And so I have already captured the weight, the thickness of the sample, and the moisture content in our software.
Okay.
And that is required for all samples before testing.
Okay. So now, while this is a piece of wood siding, what other kinds of materials might you test?
Yeah, so we can test shingles, we can test just regular plywood, and we can also assemble complete roof deck assemblies with the shingle, underlayment, and plywood underneath.
Okay, so lots of the different building material components that we talk about can be tested in the cone calorimeter.
Yes, absolutely.
Okay, awesome. So what's next to get that piece of wood siding ready for testing?
So it's wrapped in foil. The information is put into our software, and I think we are ready to start a fire. Are you ready?
I'm ready. What do we get to press?
Okay, so first and foremost, we are going to make sure that we're reading about 20.95 on the gas analyzer, which we are. All of the information is put in, and we're going to start this. The pre-run calibrations take about 10 seconds. At that point, I'm going to tear the sample holder onto the 3 prongs sticking up above the platform.
Okay. What are those 3 prongs?
So that is our load cell. And so what that does, it is capturing the weight of the sample throughout the entirety of the test, and it's taking measurements once per second.
Tons of data being collected as you run these tests, Dory, and all of that's so important to all of the research that our team here at IBHS does. You're putting that into the cone. All right.
Okay. All right, so we have teared the sample holder.
Okay. And now we can put our piece of wood in there?
So actually, at this point, I'm going to start the 60 seconds of baseline data.
Okay.
So this is required for every sample. So I'm going to start the baseline. I'm going to let that go and prepare the sample in the sample holder assembly.
Okay, and we can see data starting to appear here as that baseline information is being captured. You're loading up the sample now, this piece of wood siding, getting ready for testing.
One thing I'd like to add is that I'm adding a thermocouple on the back side of the sample. And so what that is going to do is capture the temperature of the background of the sample to show the heat penetration throughout the test.
And that's that wire that we see, right?
Yes, that is correct.
Is that part of the ASTM standard, or is that unique to IBHS?
That is unique to IBHS, and it's something we've started implementing in our shingle testing and wood siding as well.
Okay. So we're waiting for that 60 seconds to elapse for all of the baseline data. You've got the sample ready to go. And this is the sequence that you go through repeatedly each and every day. All right. Now we're loading that sample up. Once you've got it loaded, what are we going to be watching for here? You said we're starting a fire.
Yes, so give me 1 second. I've got to hang the thermocouple wire out of the way to make sure it does not catch fire.
That's important. All right. We're watching as data continues to be captured on the screen. And it looks like we're all set.
Yes, so we are all ready to start our fire.
Okay.
So what we're going to be looking for on this screen, we're going to be watching the heat release rate on the top graph, and we're going to watch the spare thermocouple temperature, which shows that heat penetration on the back side of the sample.
Okay, and what's the heat flux for this one today?
So we are burning at 40 kilowatts per meter squared.
Okay.
It's approximately 700 degrees Celsius, which equates out to about 1,400 degrees Fahrenheit.
That's pretty toasty in there. and the variable that we're watching for here is how long it takes to ignite, right?
Absolutely, and that is something that I manually mark, so it takes a lot of concentration. I'm going to turn away from you, but I will talk you through what you're seeing from the start of the test up to ignition.
Okay, perfect. Let's get going.
All right, so I'm starting the test now.
All right, press the button.
So what you saw there is the shutters open up, and that now exposes the surface of the sample to radiant heat. You can see the sparker igniter in the middle of the sample there. And what you're going to see in just a few seconds, you're going to start to see some off-gassing happening from the radiant heat on the surface of that sample. And that is going to start to get a lot more ferocious over these next couple of seconds. You can see it start to pouring out there. And in about 10 to 15 seconds, we should have ignition that's covering the entirety of this surface.
Okay, so we're all watching very carefully, and this is what you do each day for this standardized.
All right, so we have ignition, and the great thing about the cone calorimeter is that we're going to be able to watch everything happen in real time.
All of that data. So what happened? You've got a fire now. What does that tell you?
So it tells me that at 47 seconds of exposure at a heat flux of 40 kilowatts per meter squared, this wood siding would ignite.
Okay, that is the important piece of this test. That's the data that the research team is after with each one of these tests.
Yeah, absolutely. And the beautiful thing about the cone is that it creates this beautiful data packet that has everything captured. So we're able to capture the oxygen, the carbon monoxide, and carbon dioxide throughout the entirety of the test. The load cell is capturing the weight as that material and fuel load is burning away. And now we have this thermocouple data that's showing how the backside of that temperature is reacting, because of course we can see what the surface is doing.
We see that quite clearly here as it burns. How long do you let these samples burn when you're running this test?
Yeah, so this is going to go until we have flame out. So flame out is another parameter that is manually selected.
Okay.
And then we're going to let the test go for another 2 minutes just to capture any residual data on the back end of the burn.
Okay. So how many of these tests can you run in a day?
Well, that is a loaded question. It truly depends. And it depends on a few different factors.
Okay.
It depends on the material that we're burning, whether it's shingles, wood siding, complete roof deck assemblies. It also depends on the heat flux because, of course, as we ramp that heat flux higher and hotter, we can have ignitions very quickly.
Okay.
As we make it really low, they happen to be very slow. And sometimes we could have no ignition at all.
Okay. So what do you do now? Now that the sample is burning, we'll watch it. We'll watch for flame out, you said?
Yes.
And that's the next thing we're going to mark. So as you're collecting this data, what else are you paying attention to as the lab technician?
Yeah, that's a great question. So typically in a day-to-day setting, I am taking very detailed notes on the flammability and fire behavior. So I like to notice how the flames are interacting with the surface of the sample. Sometimes on shingles, there can be flames on one section of the surface area and not over the entirety. So I like to note what we're seeing, where the flames are, when the center of the sample extinguishes. That's a really important thing. But yeah, so for this wood siding, it is going to burn, and in a few seconds, we're going to actually see those flames ramp back up.
Okay, so we're paying attention here to its flame behavior, and here we're seeing how that radiant heat led to flames, those different mechanisms of ignition that we're always talking about here at IBHS. We have two of those in play here.
Yeah. So what's going to happen, and we will get to see that on the heat release rate data, we're going to burn through all of the fuel load on the top layer of that sample. And then you're going to start to see that heat release rate pick up in a little bit. And that's because we are getting to the next layer of that wood siding sample, which allows for more fuel load to be burned.
I see the thermocouple temperature really starting to climb in the last 100 seconds or so. Fascinating, Dory, which you get to watch every single day. And this kind of testing, we can do so much more of it than the full scale testing. You're able to test multiple materials in one day and see how each material behaves in a standardized way. And that goes back and forth with the full scale work that we do. It all feeds together, doesn't it? Yeah, it really does. And I'm very glad to be a part of something that can affect so many people on a large scale. Absolutely, we all are. Okay, so I see those flames going once again. What do you notice at this point, Dory?
So what I'm noticing is that, of course, like you pointed out, that thermocouple temperature on the backside of the sample has started to increase again. As you can see on the heat release rate graph, you are starting to see an uptick in the heat release rate. And you can also notice the visual flame intensity has increased. The flames have gotten, vertically higher. There's more fire, happening. And it's really interesting to know that fire is going through each layer of the sample.
Absolutely. It's fascinating how you can see that from just this data that we see on screen. And that smoke is going up into all of the data that you calibrated, the analyzer and the laser that you talked about.
Yeah.
What's happening with that kind of data as well?
So I'm going to direct your attention to the bottom part of the screen. So all of the different calibrations that I talked about, every single parameter is getting captured once per second. It's not just the weight. So that is going to be the gas values, the smoke production rate values, that heat release rate, and thermocouple temperature, of course. But this is what really makes the cone a great piece of instrumentation, because you're able to capture all of these parameters at once, and it's once per second for everything. It's a lot of data that can really lean into the material properties for flammability.
A lot of data in a controlled, repeatable way. They can give us a really large sample of data to analyze it. I'm watching those flames now. How long do you want to let this run, Dory?
So I'm going to let it go until there is no more flames visible. And so it typically takes about 10 minutes for the sample of wood siding to burn to completion.
Okay. And once this test wraps up, what will you do then?
So, like we talked about earlier, we're going to mark the flame out. We're going to let it go for an additional 2 minutes just to capture any residual data. At that point, I would be ready to take out the sample holder, prep the next sample, and keep the samples burning.
Keep the process rolling right along. All right, well, Dory, this has been a fascinating look into what is your everyday doing some of the controlled, repeatable, standardized materials testing that is so important to how we understand the overall wildfire problem and all of the different materials that make up our homes, our businesses, our buildings. Thank you so much for sharing that with us today.
Thank you. It was great to be here.